Dear all, I welcome you for the lecture session Waste Characterization and Source Reduction. This is Dr. N. Ramesh, Professor Civil, K.S.Rangasamy College of Technology. Introduction to Waste Characterization. Waste characterization is the systematic study of waste quantity and quality, which helps in planning, collection, treatment, recycling, and disposal systems, essential for selecting appropriate waste management technologies. So, we should know about the characterization of waste. It may be a biodegradable or non biodegradable, or it may be a hazardous or recyclable, and that physical characterization or chemical characterization or biological, everything it should be taken into consideration for the study. Here, the waste management, which is going to be mainly five important components. First one is analysis, second one is collection, third one is transportation, fourth one is recovery, and fifth one is recycling or disposal. Here, the five components are taking the crucial role for the waste management and the minimization of waste. Waste generation rates and variation. Quantity of waste generated per capita per day. It varies with population density, lifestyle and income level, seasonal changes, urban versus rural areas, and it should be expressed as kg per person per day or tons per day. Physical properties of solid waste, organic waste, food waste, yard waste, and recyclable waste, paper waste, plastic waste, metals, glass, and inert materials, dust, ash, stones, and others, textiles or rubber or leather. Here, that wastages are expressed in the different color coding. The food and green is almost 44, and glass it is almost 2 percentage, metal 2 percentage, and others are 14 percentage. Paper and cardboard it is 12 percentage, and plastics is 17 percentage, and rubber and leather are around 12 percentage, and wood is the 4 percentage. Chemical properties of solid waste: pH value, calorific value, carbon nitrogen C-bar ratio, volatile solids and fixed solids, presence of toxic elements. It is the chemical properties of solid waste. Here you are seeing in the photos, it is the different type of waste are shown in the here. It is a plastic waste and biomedical waste, and all the waste are shown in this photo. So biological properties of solid waste: the biodegradability, presence of microorganisms, rate of decomposition, methane generation potential, and compost life cycle. It is a food is next it is converted into scraps, and it is go for compost, and it is becoming a fertilizer. Finally it is used for the growing the plant. Again it gives the food. It is like a cycling. It is a compost life cycle. Here you are seeing the diagram 1, diagram 2, diagram 3, diagram 4, and diagram 5. So it's like a vessel composting. Here the putting the holes in the vessels, and and the waste is putting in the vessel, and finally all the waste are dumping. After that, ensure the whole pile is moist, not dry or wet. Do not add water. When the bin is full, allow up to stabilize so that more heat is generated. So repeat recovery for 2 weeks or 4 times, 3 weeks to 4 times. After 2 weeks, turn for the over composting, which is shown in the figure. Finally, it is converted into good composting. Hazardous characteristics of waste: ignitability, easily catch fire, corrosivity, acid or alkaline nature, reactivity, explosive or unstable, toxicity, harmful to humans and environment. Here, so there is a warning signal is given for the various dangerous type of waste. It may be a toxicity, corrosivity and radioactive like this, which is given in the photo. TCLP, Toxicity Characteristics Leaching Procedure Test, determines toxicity of waste, simulates leaching in landfill conditions, identifies presence of heavy metals and toxic chemicals, used to classify waste as hazardous or non-hazardous. Here, there is the experimental setup is given for the extraction of vessels containing soil and extraction of fluid. In the A, it is the peristaltic pump also there. So it's like a simulation how it is going to be working as a in the field we are seeing. Waste sampling and characterization plan, define objectives of sampling, identify waste sources, select sampling method and frequency, collect representative samples, analyze physical, chemical and biological properties. Here you show how the waste is collected and transported into the vehicles. Source reduction of waste, reducing waste at the point of generation, efficient product design, use of reusable materials, minimizing packaging, promoting sustainable consumption. Waste hierarchy, prevention, and then preparation for reuse, recycling, recovery, and finally it come for the disposal. Waste exchange, transfer of waste from one industry to another. Waste used as a raw material or fuel, reduces disposal cost, encourage industrial symbiosis. You see the supply chain cycle. It is a shutterstock. It is from the industry to consumer. So what are the different process or takes places you are seeing in the figure? It is food waste and finally it is going to be transport and it takes for the consumer. Extended producer responsibility EPR, producers responsible for the post-consumer waste, applicable to plastic, e-waste, batteries, encourages eco-friendly product design, promotes recycling and safe disposal. It is the main points involved in the EPR. It is a product life cycle. So it is the introduction, growth, maturity, finally decline. It is the important things it should be keeping in mind of the product cycle. Recycling and reuse, recovery of useful material from waste, conserves natural resources, reduce landfill load, save energy and cost. So it is also the diagram which is going to be how to managing the waste. Practical. It's some composition of municipal solid waste, collection of representative waste sample, manual segregation into components, weighing each component, percentage composition and calculation. So it is this is the photos which is shown in the metal. What is the color coding? Paper, plastic, glass, organic and e-waste. How we are going to consider the various categories of bins for collecting the waste and it is taken for the treatment, recovery and landfill. Determination of physical properties of MSW, moisture content test, density measurement, particle size analysis. Here it is the moisture meter shown and pH determination, calorific value measurement, C bar in N ratio calculation. It is a bomb calorimeter which is shown in the figure. Thank you for watching.